So it looks like next week, next Wednesday is also holiday, right? So we don't have a class. So probably we have to have a quiz on the next week after that. So first quiz, October 16. So actually we should have had a quiz on sometime in this September, so it's going to be actually a second quiz. So I'm going to have a 2-hour quiz. So in a way, you can replace the midterm exam. We don't have a 중간고사, we don't have a midterm, but the first quiz will actually, in a way, is equivalent to the midterm. It's going to be 2 hours. So 15 to 17. And you can prepare 2 pages of cheating sheet. So you can write down everything you like, including the proof of something. So that means for the coming quiz, you don't have to memorize. You don't have to memorize, right? But the level of difficulty will be somewhere in the middle. Two hours. And the question will be in English. You don't have to write down in English. So you can write down in Korean, that's okay. Answer in Korean is allowed. Korean. Or any other language is allowed. Or any other. It's okay, but English is preferable. You can bring dictionary. But no text. No KakaoTalk. No line. Whatever. So exchange of information between your friends is not allowed. That means you can not exchange information with your friends. The most important part is 2-page of cheating sheet and handwritten. And the topics for the quiz from the first class to whatever we are covering today. So approximately 4 weeks of class. So before I proceed, any questions about the quiz? So I think I gave you a number of homework problems. I think that would be wise to practice those homework problems at home. For example, checking tangent Z can be a good exercise. It's 2 hours, and normally if you don't practice, it will take about maybe half an hour to 45 minutes to derive the Cauchy-Riemann condition for tangent Z, and there are plenty of chance that you can make a mistake because you have a complicated form of denominator and denominator, right? So practice will make perfect. So if there is no question, then can I assume that you understand what we are going to face in 2 weeks for quiz? Yes.
May I ask to explain that information in Korean again?
Yeah, sure. You can ask me in Korean too.
아까 밑에 딕셔너리 내용을 한 번만 한국어로 설명해 주실 수 있어요? 정확히 이해를 못해서.
이게 시험이 영어로 다 나와서 사전 갖고 와도 된다고. 다만 친구들하고 카카오톡이나 뭐 라인이나 텔레그램으로 정보를 교환하는 건 안 돼요. So am I clear? One more question? 계산기, yeah, 계산기를 쓸 일은 없을 것 같긴 하지만 you can bring calculator, but you cannot use a programming function. 프로그램 펑션은 쓸 수 없고 그냥 계산기 갖고 와도 돼요. Any questions? Any further questions? Yes. Okay. 기출 문제는 온라인 강의실에 올려놓은데. So the previous exams, the previous quiz problems will be in the online lecture room, and maybe this week, right? Yeah. So let's review Cauchy's integral theorem. So this is curve D. So D is called domain. Its definition is a region of space enclosed by the closed contour C. Enclosed by a closed curve notion for the orientation of curve is counterclockwise. So standard default notion is counterclockwise for C. So theorem says if Fc is analytic in D, then equal to 0. Analytic means Fg is finite and differentiable. Exemption is this function. Here C is unit circle. But this function is not analytic when n is negative, right? Because when n is negative and when z naught is inside of D, then it's not analytic, right? So the answer is the following: 2 pi I delta m minus 1 that we showed in the previous week, but just for you, probably you have forgot for in week's period. I'm just going to repeat. And C is unit circle centered at C naught. So probably I will let you copy. Let's consider unit circle. Then any point on C, let's say Z, Z can be written as Z naught plus exponential I theta, right? So any point on the circumference is 1 Jew. So any point. The circumference. You can write it down this way. Then Z minus C naught is exponential I theta. D Z minus C naught is actually dz is exponential I theta I d theta. So C is Fz dz is I m theta I exponential I theta d theta. C to the m. It's actually Z minus C naught to the m. I m plus 1 theta d theta pi I delta m minus 1, right? So we have shown that in previous class. So when m is equal to minus 1, that's 2 pi I. Otherwise, it's all 0. And this is very important property. How about when MC is not the unit circle? Another case is Number 2. Oh, thank you. Sometimes this kind of thing happens. It's called the Murphy's law. So C is a circle of radius R. Yes?
I think the screen doesn't work.
Oh. Screen just stopped. Right. So when now C is not the unit circle, but the circle with the radius R. Okay, let's say C prime. Confusing. So this is Z naught. Say this is R. This is Z. Then how do you represent the point on this new circle? It's very easy. Z, of course, Z naught is same, right? But you can say R exponential I theta. So Z minus Z naught is R exponential I theta. D Z minus Z naught is dZ is R exponential I theta I d theta, right? So C prime C minus C naught to the M dz is same, still 0 to 2 pi. But now this is R to the M exponential I M theta M exponential I theta I d theta. So this is I R to the M plus 1 exponential I M plus 1 theta d theta, right? 또 멈췄다. Let's get stuck again. 왜 그렇지? Mm-hmm. All right. Somehow I have a premonition that this swing will repeat and repeat today. I don't know why, but it's called Murphy's Law. If something is going to go wrong, it will go wrong. So don't be surprised if the screen stopped again. I don't know, something. But this part we already know. This is delta m minus 1, right? So what happens if m is equal to minus 1? This becomes 0, right? So r to the 0 is 1. So whether this circle is a unit circle or circle with radius r, it doesn't really matter. The answer is same. So it is 2 pi I delta m minus 1. What happens if it is another circle? If C is arbitrary curve? Say this is just C. We have a point. I can make a bit of a something like this. So this is C prime, C1, C rho. So this is rho circle, and C2. And let's say the gap is something like epsilon. Then the original closed curve this becomes C prime. C prime. Sorry. I think I should change this a little bit. C1, C2, C3, C prime. C prime is C1, C2, 0 plus C3. 0, C3. Okay. Consider the C prime curve. So C prime curve is composed of the C1, C2, 0, and C3. So let me ask you a question. In this new diagram, this particular point Z naught, is it inside or outside of C prime? The C naught point. Inside or outside? Outside, right? Obviously. So for this one, C naught is outside of C prime, right? Therefore, what happens? This integral, C prime, will be 0, right? Let me just say again. This is very important. Now, this particular point Z now is now outside of this curve, right? C prime curve. C prime is this curve, C2, Z now, C3. And this is outside, right? So this integral will be 0. So let me draw a picture again. What happens if epsilon goes to 0? Then this is going to be contact. So then C1 curve closed integral, right? Likewise, C rho equation is 0 is clockwise, right? This is clockwise. So it will become minus of 0 what about this? C2 the direction of the integration is opposite to C2 and C3, right? So if you add them together, it will cancel each other. So it will becoming 0. Therefore, as epsilon goes to 0, the original integral C prime z minus z0 to the m dz will become closed for C1 minus 0 dz is equal to 0. So this original curve C1 is same as 0 closed contour 2 pi I delta m minus 1. So it doesn't really matter the shape of the curve. So any closed curve, say this is C1, we have two pi I delta m minus 1. So originally we have shown that this is for unit circle, and then with the circle with the radius r, but it turns out that it's for the general shape. So someone might ask me a question, why we are learning this? Say ft this is called the Laurent series. Assuming that we can represent some complex function in terms of series representation. And we are interested in finding the integral. For the C. functions can be very complicated, and it has a infinite number of components, maybe starting with bn, but actually you can go further or infinite series. So actually, the functional form can be very complicated. But we are interested in just integration part. If you integrate this, what do you get? All the terms goes to zero except this one, right? Actually, functions can be very extremely complicated. So as long as you can express in terms of series expansion, and then when you integrate, you don't have to care about the other terms. Just one term survives. It's P1. Right? That's what Cauchy found about 200 years ago. And in many cases, you need to calculate the integration of some complex function. But when you do in the complex integration, then the only information you need is this term only. So only term you need. That's what Cauchy found out. So this complex integration was more like a supercomputing for him at about 200 years ago. And he was the first mathematician to find out that any complex integration can be done just finding out only one single term. Or you can extend it for general case. Or generally PM and C is integration containing zero knot. Then likewise C 2 pi I P1. So this has a name called residue called and using this factor, the Cauchy wrote down the second integral formula. It's not the theorem, but it's called the formula. F This is called the integral formula, and I'm not going to prove that. Maybe you can take a break for a few minutes and then continue. So actually, the Cauchy's integral formula can be used the similar trick. So let's say this is C, and we can do similar thing. So C is C1, C2, C0, C3, epsilon. So C can be written as a C1, C2, 0 plus C3. The C integral let's say this is a new C prime. C prime C2 0 C3. And in the limit, when epsilon goes to 0, this integral, C prime, closed integral, right? C2, C3, goes to 0, right? Because C2 and C3 are in opposite direction. And here, 3, 0, goes to minus of C contour integration 0. And it goes to 0, right? Because Z naught is outside of C prime. Therefore, same as this 0, but f z naught plus rho exponential I theta dz, right? Was this is 0. And we can actually set rho very small. We can set as we set rho goes to 0, it becomes fc naught dz. It's 2 pi I fc. So that's the proof of a Cauchy's integral formula. It's QED. So Cauchy's integral formula is, you can be proved very, in a way mathematics is more like a painting. You just draw something. So question is how to find the B1. That's a fundamental question, right? FC So you can check the limit when z minus c naught to the n, you multiply the polynomial to the f of z and take the limit, and it become finite, like this case, right? When bm is not equal to 0. we only need to find out B1, which is called residue. So let's consider the case when we have a polar order M. Then how to find B1? Fg times B minus Pm plus Pm minus 1 Z minus Z naught plus P1 etc. etc. So how do we find P1? So how do we find So we only need to find P1. How do we find out that? Differentiation by Z n minus 1 times, right? So dz m minus 1 m minus 1 factorial p1, right? It's very simple. p1 is m minus 1 factorial tzd m minus 1 fc m set c equal to 0. That's the formula we need to. For example, in case you need to copy, I'll just let you copy the formula. Okay. Okay, for example, so can you find the pole, the location of poles? How many poles do we have in this case? How many poles do we have? 2. Pole Z equal to 1, Z equal to minus 2, right? Order is order 2. Order 1, right? So we have a 4 of order 1, order 2, that's equal to 1. 4 of order 2 and 4 of order 1 minus 2. So order 1 is simple. Just take the limit z plus 2 fc minus 2 1 over 9, right? How about the second pole? We dz square fc dz c plus 2 minus minus 1 over 9. Another one. Just finding the residue. So this is simple, easy, right? Not too difficult. A little bit more complicated following. Finding residue. Sometimes we write down this way, residue f zeta. We write this way. This is notion. When fc 1 over sine z. So can you find 4 of this function? fc is 1 over sine z, and sine z becomes 0. The 0, pi, minus pi, 2 pi, etc. right? So fg has a pole. So has poles at z equals to 0, plus minus pi, plus minus 2 pi, etc. etc. Order so let's try to find out the simplest case, whether it's a simple pole or pole of order 1. So let's check. How many have learned L'Hopital 정리, L'Hopital theorem in calculus? So 1, 2. I think actually every one of you have taken, probably learned about L'Hopital theorem, but probably forgot. So I'll make a brief statement about L'Hopital theorem. It's a French mathematician, L'Hopital. then same as that's the basic statement about L'Hopital theorem. That is, f z naught is 0, g z naught is 0. Say c is z0 plus delta, then same as delta goes to 0, f z0 right? So L'Hopital theorem is satisfied when both denominator and nominator it goes to 0 when z goes to z naught. That means f z naught is 0, g z naught is 0. So let's say z is z naught plus delta. Then this limit is same as delta goes to 0 by z naught plus delta, f z naught plus delta. And so actually, the formula can be written as the following. Right? Because this is 0, this is 0. So it doesn't make any change when you subtract 0 on both sides. And then minus delta delta. If you divide the numerator by delta and also divide by the denominator by delta, it doesn't change, right? But this turns out to be simply g prime z naught f prime z naught. So that's L'Hopital theorem. Therefore, so when probably I have to replace the tip. Let's say same as L'Hopital's theorem. 1 cosine z, right? So 1. F over z is 1 over sine z, has a pole of order 1 at c equal to 0. And likewise, we can do the same thing for plus minus pi, 2 pi, etc., etc. So residue of sine z is equal to 1. How about another example? FC in real variable, exponential is never 0, never less than 0, right? So in real variable, this function doesn't have any pole, right? But how about in complex domain? When exponential c become minus 1, pi I, minus pi I, 3 pi I. So in complex domain, exponential z is minus 1 at z equal to plus minus pi I, 3 pi I, etc., 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 right? So let's check whether it does have a pole of order 1 or higher poles. We can just multiply by z minus z plus pi I. So check this. You can use L'Hopital's theorem. One by exponential z minus 1. So the residue f pi I is minus 1. For the next 2 weeks, I think after the quiz, we are going to cover various kind of complex integration. But today, let's just start with a very simple case. That previously I mentioned about the British invasion of France during the French Revolution. That you can calculate the height of the tide by the following integration. That this integral. That's actually integral for tidal force. During 1800 war in Europe. calculating the tidal force and height of the tide is very important for the national defense or offense in those cases. And so the French mathematician was more concerned, especially Coase, was concerned about the national defense. So he has to find out exactly how the height of the tide can be on some particular date. So we decided to calculate this function. So you can convert this integral into complex integration by C, unit circle, C exponential I theta. That's what Coase did, actually. Cosine theta 1 over 2 exponential I theta plus exponential minus I theta, right? So that is 1 over 2 z plus 1 over z. dz is exponential I theta, I d theta, or d theta can be I exponential I theta over dz, I z dz. So Coase converted this integral into the following. Closed contour integration, d theta will become Iz dz, a plus p over 2 z plus 1 over z. That's what Coase did. So maybe I'll just copy and paste. Nice, right? So it becomes 1 over I dz times a plus p over 2 c squared plus 1, or 2 over ib c squared plus p over 2az plus 1 over 1 z squared plus p over 2az plus 1 is equal to 0. So we have two poles, minus a over b plus minus root a over b square minus 1 p over a plus minus 1 over b a square minus b square. Say c1 minus a over 2 plus 1 over b a square minus b square. c2 minus a over 2 minus 1 over b a square minus b square. Definitely this is less than minus 1, right? And this one must be between minus 1 to 1. So we have the following. Let me check, right? I becomes 2 over IB C minus C1 C minus C2 dz. C1 is minus A over B minus plus A square minus B square. C2 is minus A over B minus A square minus B square is less than minus 1. So we have 2 poles. C2, C1, C. So we have only one pole inside of this circle, right? So only C1 equals Z1 is enclosed by a closed curve C. So therefore I is IB 2 pi I residue F C equals Z1, where FZ is this C minus C1 C minus C2 over 1. So 2 over IB times 2 pi I residue is simply this Z1 minus Z2, right? Or 1 over B. 1 over B. So 2 over B, square root of A square minus B square, 2 pi I. So this cancels each other, this cancels. 2 pi square root of A square minus B square. Maybe one more example. Any questions? Example. So actually, this already you know the answer. We know that dx, the tangent of x is what? 1 plus, right? So this is actually dx is tangent infinite minus. What is arctangent infinite? Pi over 2. How about minus infinite? Minus pi over 2. We know the answer already, pi. The question is whether we can do this using complex integration. So let's consider the following integral. We have two poles, right? 1 minus 1. Consider the following integration, minus r to r, c1, c2. This integral, c is c1 plus c2. What happens? It does have one pole, right? So you can apply Cauchy's integral formula. Simply 2 pi I, right? But this is C1. Oh, no. Plus I, minus I. So FC. It's not 2 pi I. I think I made a mistake. Must be 2 pi I times residue FC plus I, right? That's the correct formula. So residue to I. So this is actually 2I become pi I. Pi. C1 becomes minus R, minus R to R, x squared plus 1 dx, right? So on C1, C become R, right? On C2, zero to pi r square exponential I 2 theta plus 1 I r exponential I theta d theta. So absolute value r goes to infinity. Therefore, this closed integral becomes minus infinity to infinity x squared plus 1 dx pi. So it turns out that they actually know the real integral part. This complex integration also produces the same result. So we are going to use this technique on and off in the next few weeks. So basically, C2 integral is going to 0. On C2, C becomes R exponential I theta, right? And denominator is I squared. So it's roughly 1 over R. And when R goes to infinity, 1 over R becomes 0, right? So this C2 integral doesn't contribute to this integral. And the C1 integral becomes real integral. So the result becomes pi. Maybe you can stop today here. So this is the problem for quiz. So good luck with the first quiz after 2 weeks. And we are going to put the previous quiz in the online lecture room. And I'm going to put this lecture on YouTube tonight.